So welcome back to the channel. Thank you for being here. It's always a pleasure to have you here as we study and learn mathematics. This is Pendulmatics, your complete online school of mathematics, and I'm your tutor, Pendulum by name. Welcome back, and we are still looking at indices, logarithm, and so on. I told you this is a wide topic. We're now on the logarithm aspect, and in this video we'll look at simplification of logarithms part 1. Alright, so basically we'll be looking at how we can simplify these questions on the board, which we should do very quickly. They are not difficult. I don't believe that any part of mathematics is difficult. It's just a question of understanding how it is done. Alright, so welcome. If you're new to the channel, please don't forget to subscribe. Do it now. Hit that subscribe button and then turn on the notifications, ring that bell, so that whenever we make new videos, which we do pretty regularly, you'll be notified to be the first to come and watch and learn. All right, so let's go into it. We'll be resolving. We have about 6 questions here, so I think this should be enough to drive home the concept of what we are doing here and to make it very clear. Alright, so as we go on, if the video is helpful to you, you learn something from it, don't forget to like the video and don't forget to drop your thoughts in the comment. I love reading from you to know what you think about the video, and then finally share this video to your friends, to your colleagues, to your classmates, on your WhatsApp status, wherever you can share it. Alright, so let's begin. Now we are asked to evaluate these without using tables. Basically, logarithm is divided into two. We have the theory of logarithm, which is what we are starting with. That's the part of logarithm that do not involve using tables. Alright, so whenever you see evaluate without using tables, you basically know that you're looking at the theory of logarithms. So then your mind should go to two places. If you watched the last video, we looked at the laws of logarithm. That's the first place your mind should go. How do you apply the laws of logarithm to solve these questions? And then the relationship between indices and logarithm. When I told you that, recall that if we have something like this, log, let's say a base y equals to x. If these are logarithm, if we are changing this to indices, it's going to give us y raised to the power of x is equal to a. Always remember this. If you have a logarithm like this, if you want to change it to indices, the base of the logarithm will still be the base of the indices. The answer you get on the logarithm side will now become the index or the power for the indices, and then this number here in front of the logarithm becomes your answer for the indices. If you can put this relationship in your head, you will not find it difficult to resolve many logarithm problems. So if you can remember this, and you also remember the laws of logarithm: addition law, power law, multiplication law, inverse law, change of base, and reciprocal law. If you remember all this, you will have questions with this. So this is the first part of indices, like I said, where you're evaluating without tables. This is basically, first part of logarithm, not indices, logarithm. So basically here we are looking at the logarithm of numbers to different bases. Then the second part, which we do after this, is the natural logarithm of numbers. And in that case, we'll be only considering, or that section only considers the logarithm of numbers to base 10. So in that section, we'll not be using tables. So take note of that. Once you see without using table, your mind should go to theory of logarithm. And when we talk of theory of logarithms, remember two things: this relationship between indices and logarithm, and then the 7 laws of logarithm that we have treated. Alright, so now if we remember this, let's use them to solve 1a. Now given that log 0.2 base 25 is equal to x. Now convert to indices following the same principle, convert to indices. This base will be the base. This answer for the logarithm part becomes the power for the indices. So 25 raised to power x is equal to 0.2. Now this number becomes the answer. Now the only thing left to do now is find a way to express these two in the same format. Alright, so 25 raised to power x. Now we know that the only way to express 25 basically is in powers of 5. So this side will be in powers of 5. Let's see how we can put this side also in powers of 5. Now 0.2, if I'm changing it to fraction, is going to be 2 over 10. Right? 0.2 is 2 over 10. 2 over this dot is 1 and this is 0. Now this is 5 square, right? Raised to power x. 25 is 5 square. Then everything raised to power x. And I can write this one as 1 over 5. 2 into 2 is 1. 2 into 10 is 5. So if I multiply these two powers, remember your power law in indices. I have 5 raised to power 2x is equal to, now I can write this as negative index. Alright, 5 raised to 1 over 5 is the same thing as 5 raised to power minus 1. Negative index. Alright, remember I told you minus means reciprocal, 1 over. Now you can see here that the bases are equal. Okay, so you can equate powers. And if I equate their powers, because the bases are equal, if I equate their powers, I have that 2x is equal to minus 1. Now to find x, what do I do here? Just divide here by 2, divide here by 2. So that 2 can cancel itself and only x will stand here and minus half. So our answer is that x is equal to minus half. Alright? So that is the answer here. X is equal to minus half. So just always remember, you are either going to apply, once you are asked to resolve anything under the theory of logarithms, you're either going to apply this relationship where you convert from indices to logarithm, or you apply the power. So in this first part, this simplification of logarithms, part 1, we are mostly going to be converting from indices to logarithm. Then in the part 2, simplification of logarithms 2, we are going to work with the laws of logarithm more. Now B gives us log 9 root 3 base 3 is equal to x. Now same thing, let's convert to indices. This will be 3, x will become the power, is equal to 9 root 3. I've converted this logarithm to indices. This raised to this power is equal to this. Now we basically can't touch this one here, so we leave it like that. Now 9 is 3 square, right? 9 is 3 square. And 9 root 3 means 9 times root 3. So I can write this as 3 squared, that's 9 times. Root 3 is 3 raised to power half. We did this under indices. We looked at fractional index. Alright, so root 3 means 3 raised to power half. Square root is half. Cube root is 1 over 3, and so. So this one will still basically remain like this. Now, remember, multiplication law under indices, because they have the same base, I take one of the base and then I add their power. So 2 plus half. 2 plus half. I add their powers. 3 raised to power x will be equal to 3. Now 2 plus half is 5 over 2. I don't think I need to start explaining how we got that. You should be able to add fractions. 2 plus half is 5 over 2. Alright, that's 2.5. So we're going to have this. If you add these two, please. 5 over 2 came from adding 2 plus 1 over 2. Alright, 2 plus 0.5, that's 2.5. Now here, we're going to equate powers again. The bases are the same, so we equate powers. And we have basically that x is equal to 5 over 2. So this is as simple as this. X is equal to 5 over 2. So you can see that this is actually not so difficult. once you're able to convert to indices, I want to do a lot of examples so that you see it. But if you're able to convert to indices, then you basically don't have any problems. Alright, so let me do, I think maybe I'll leave some for you as assignment. Okay, I will leave for some as assignment. So I'll leave this one for you as assignment C, and this one as assignment. It's the same process, just convert to indices. So you will do these two as assignments. I'll write it out for you. So let me do D. You will do C and A as assignments. 1C and 2A. Now for D, we have that log root 10 100 is equal to Y. Alright, so same thing we've been doing. Let's convert to indices. 100 is the base. Now raised to this power is equal to this number. Same thing. This base raised to this power equals to this. Now I can write 100 as a power of 10. So this will be 10 square, then raised to power y that is already here. And then root 10 is the same thing as 10 raised to power half. Alright, just like we did here. Square root is 1 over 2. Now if I open here, 2 times y, this is 10 raised to power 2y, is equal to 10 raised to power half. And then basically, I will equate their powers. And if I equate their powers, I have that 2y is equal to 1 over 2. Now, for me to find y, I divide here by 2. And then I divide here also by 2. Meaning I'm going to have that y is equal to 1 over 2. Now, if you're dividing, it's supposed to be 1 over 2 divided by 2 over 1. That's this part. 1 over 2 divided by 2 over 1. Which I can write as 1 over 2. You change the division to multiplication and then you invert this one after the sign. So times 1 over 2. Y is equal to 1 over 4. That's all. As easy as selling pie. Alright, so let me do 2b. I'm going to do the other one as an assignment. This video should be a short one because this is as simple. Alright, like I told you, mathematics is not hard. Understand the concept and you'll be able to solve all this. Now we have this for this. Alright, so same thing. If you're converting to indices, y raised to power 4, y will still be the base, raised to power 4 is equal to 81. This raised to this power is equal to this. Now y raised to power 4, what you ask yourself, how can you express 81 to the fourth power? So what is the number that is the fourth root of 81? That is the number that will multiply itself 4 times. Since this side is already raised to power 4, what number will multiply itself 4 times to give you 81? And that number is 3. So 81 is 3 raised to power 4. 3 times 3, 9. 9 times 3, 27. 27 times 3, 81. Now in this case, you can see that the powers are equal. So if the powers are equal, you equate bases. Alright, so in this case, you equate bases. Or here, we have been equating powers. Why? Because the bases are equal. Bases are equal. Bases are equal. We equate their powers. But in this case, the powers are equal. So we equate their bases. And this just gives us that y is equal to 3. Alright? So this is as simple as ABCD. In fact, it may even be more simple than ABCD. So try these two as your assignment. Alright? This one and this one. Let this be your assignment. Alright? I've done this one for you. Alright, so this one says the logarithm of, okay, maybe I should write it. Let me make it bigger so that you can see it clearly. Let me make it bigger. Assignment. Okay. Evaluate without tables. Number 1, the logarithm of 1 over 27 base 81 is equal to y. Number 2, the logarithm of x base 9 is equal to half. So this is your assignment. Try it for me, try it for me, try it for me. Now, like I said, just remember this. So this raised to this power is equal to this. And then try to put all of them in the same base. Of course, once you see 81 and 27, you know that you can put them to base 3. Alright, so remember your application of the laws of indices. Then this one, the same thing, 9 raised to power half is equal to x. Alright, so 9 raised to power half is equal to x. 9 raised to power half means square root of 9 equals to x. So that this one even solves itself. Alright, so that's all for this video. It's a simple video, it's a simple process of simplifying logarithms by converting to indices. Alright, you mostly use this when you have just one logarithm to simplify. Alright, so just like in all these cases. But in the second video, we'll look at simplification of logarithms part 2. We'll have a combination of logarithms. So one logarithm being added to another one, or one logarithm multiplying another one, or one logarithm dividing another one. Alright, so in that case, you will now have to apply the laws of logarithms. So keep an eye out for that video. It will be up on the channel very soon. If you like this video, if it helped you, if you understood it very well, please drop a like on the video and drop a comment as well. Let me know what you think about the video. Don't forget to share it to those that need it, your classmates, your colleagues, your children. Put it on your WhatsApp status. Let other people learn how this is done. All right, subscribe to this channel and turn on our notifications so that whenever we post a new video, you'll be informed and you come and watch and learn. Thank you so much. I'll see you soon for the